Hi, my name is Thanakorn Phothong. Today I'm going to show the process of making a digital key lock with a passcode 0065. I'm going to explain in 5 parts. I will be using 10 switch is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From the passcode 0065, we know that necessary switch are 0, 5, and 6. 0, 5, and 6. All the other switches I will be joined together a parallel circuit and call it the no switch. Then check all the switch, the use switch and the use switch, and join them with the OR gate and call it the OR switch to be used in the future. And the requirement before becoming switch 0, switch 5, and switch 6 is the passing switch 0. We need to end them with switch 5, switch 6, and switch no with bar. When we join them switch 0 in the circuit, we use AND gate. This is the equation of switch. In this project, I will assign 10 steps to fill all the requirements such as place any switch to make the lights go off. And I will assign Roman number is the input. First, 1 at the first input, 2 at the second input, 3 at the third input, 4 in the first 4 inputs, all as the case possible. And start of state is 0 or start. If there is no switch, press a sign equal to 0. If press 1 equal to 1, it will change to state A1. If we are still press the switch, the state will still stay in A1. If stop press, it will be the all equal to 0 case, then change to state A true. But there are cases where we press 1 with another switch, it will jump to state A0. Now, when we know the pattern, we can do the same thing for A2, A3, A4, A5, A6, and A7. but we will discriminate to pay anything to go back. In the state X will be the state that makes the right turn on and the first state to finish the circuit. And starting at the state AX and press any switch to turn off, so we can assign that as off. And still in A9 when you press all equal to 1. But because the clock is very fast, if we press to turn off, instead AA can be assumed as pressing a relay input and skip to state A0, A1 and A2. That's why we will add one short state that is A9 to prevent pressing for a long time before going to state A0. That's why. Therefore, we will use change state and assign it to binary code at 0, 0. Therefore, we will use change state and assign it to binary code. And in the patient state and next state table, and start at the patient state column, we insert all the outpatient state. And in the next stage column, then write all the possible input that can happen. In the first 2, 3, and the last column is output. Then consider which state gets view input will change to the next state and what design in our state diagram. And example that state A0 get the first input equal to 0 is view state at the state A0. And when first input change to 1 is view change to state A1. Then consider state A1. When A1 gets 1 equal to 1 is view state at the A1. If it get the input all equal to 0, it will go to A2. And when A1 is 1 is equal to A0. Yep. If it get the wrong input as 1 equal to 1 or equal to 1, it will shift to A0. Do the same thing for every state by consider our state diagram and add a binary code for n. And output, you can shoot a state to output some state to output. You can put the one in the output in the column output. And you can add a binary code for each state. And now is the and next step table is the finish. And now present state is the finish. When we get our present state table, I assign default is Q0, Q1, Q2, and Q3. We can write our equation by consider 1 because we can consider midterm. But by considering which state come after example, what's the input state A0 get before getting to our interest state example. and finish all the static equation, and we will get one diction, then we can all is with other diction we interest in the edge bit write it. Yes, the grouping. And same grouping. Same grouping. Grouping. It is same. When you make the schematic, and when you make the schematic, you can like to the duplicate in the circuit. And the clock 0, 1, 2. There are no switch press. It will stay in the state A0. And the clock 3, press 0. It will skip to state A1. As the clock 4, press 0. It will stay in the state A1. At the clock 5, there are no space skip to the state A2. And if clock 6 has been pressed, yes, it will stay in the state A2. As clock 7 is pressed 0, it will skip to state A3 and stay in the state A3 as clock 8. And as clock 9, there are no switch pressed, it will skip to state A4 and stay in state A4 as clock 10. As clock 11, press 6. It as state 11, press 6. Then skip to state A5 and still in state A5 as clock 12. As clock 13, there are no press, it will skip to state A6 and still in the state A6 at the clock 14. As the clock 15, press 5. Then skip to state 7 and stay in the state A7 as clock 16. and don't press anything at the clock 17 and skip to state AX and stay in the state AX at clock 18. The requirement for press any switch to close will happen as a clock 19. Pressing 0 then skip to A9 and press 0 till clock in 24. Then stop pressing at the clock 25 is go back to state A0 and still in state A0 until there are new inputs. And this is the comparing table and my simulation result. I assign Q1, Q2, Q3 to be the LED light. We show what is the present state and Q is the next state. And when you press 0 in the clock 3 and 4, yes, and don't press anything in 5 and 6 is in LED in the state A2 is turned on, and next input you press 0 and the state A4 is turned on, and input 3 you press the 6 state A6 is turned on, and the last one you press 5 is the last input LED is turned on, and when you go back you can press anything, and in this one is the press 0, it just go back to the state A0. And the special part is comparing between the 9 and 10 state. And for the 9 states, when code can see that it will skip from the A0, A1 and A2. But for the 10 state, I will stay in the A0. Wait for the next input. This wrong design, I think it in the next in the state diagram.